Okay, morning. Some of you were asking about this question yesterday, so I just thought I'd do a quick run through. First of all, we're given that x plus y equals 60, and we want to know what the maximum value of x squared y is. So the first thing I do here, and I think this was where people were having a bit of an issue, is instead of having an expression where we've got x plus y equals 60, let's make y the subject. So we can change that really easily by saying y is equal to 60 take away x. The reason we want to do that is because then we can substitute that into here. So we know that x squared y would actually be x squared multiplied by 60 minus x. So I've substituted that in for my y value into the x squared y bit. If I expand that, I get 60x squared minus x cubed. I'm going to call that my function of x, and the reason I'm going to do that is because it helps me model how to find the maximum value in a minute. We know that a maximum value is just one turning point, and in order to find a turning point, we need to differentiate because we know that the gradient at any turning point would be 0. So if I find f dash x, I know that I get 120x to the power of 1 because we multiply the coefficient down by the power, and we would get minus 3x squared. Again, we know we're looking for a maximum point, which is a turning point, so we can put that equal to 0 is equal to 120x minus 3x squared. If you think you can solve this at this point, then just pause the video, go forward and have another crack at it. Be really good practice for you. I'm going to, just because I don't like having a negative x squared, I'm going to just kind of turn this around and make the x squared positive. So I know that 0 is equal to 3x squared minus 120x. Just imagine adding 3x squared to both sides and subtracting 120x off both sides. Then I'm going to factorise. I pull a factor of 3x out. Gives me x minus 40. 3x brackets x minus 40. And that equals 0. So we just need to make sure that I keep this all in view of the visualizer. That means that x is equal to either 0. If I have it in there, it'd have to be worth 0, or x could be worth 40. Now, in order to figure out the nature of a turning point, I find the second differential. So I need f dash dash x, which is 120 minus 6x. If we're looking for a maximum, then we're looking for this to be negative because we know that the graph has reached a maximum and the rate of change of the rate of change then turns negative because it turns back down. So we want f dash dash x, or the second differential, to be negative. The way that I would get this to be negative, well, if I put a 0 in, I'm going to have 120 take away 0, so that's going to be 120, so that will still be positive. So I know that f dash dash x is actually less than 0 when x equals 40, which makes that a maximum. Value of x, which is kind of what we're looking for. So we've almost answered this in reverse. We know that the maximum value of x is 40, but we need to substitute back in and figure out what the maximum value of x squared y is using that. So then you just substitute in 40 into our, remember that we rearranged x squared y to be x squared brackets 60 minus x. So if I whack my 40 in there, I've got 40 squared multiplied by 60 minus 40, or 1600 multiplied by 20, which is going to be 32 with a few zeros, isn't it? So that's our maximum value. And the maximum value occurs when x is worth 40. I hope that makes sense. If it doesn't, please let me know. If there are any other questions that you're struggling with, then please let me know as well. I hope you're all right. And well done for hitting the ground running yesterday. I know it's not hard after a 2-week break. You did really well. Thank you. Bye.